Now, presenting the certificate of graduation to Axie the Axolotl from Class 4E.
That's right, baby! Axie the Axolotl has finally graduated. And probably so will you, considering that you're watching a Sec 4 math video.
Axie the Axolotl, could you step off the stage?
Oh, anyways, you don't have to worry about O-levels because your favorite axolotl has got you covered for the last stretch of your math journey. Because I'm gonna cover all the Sec 4 topics as well as some top secret tips and tricks. So, for the last time in the series, presenting the Ultimate Secondary School Math Guide. So let's say we have Supermarket A, which sells Feastables, Prime, and Doritos, which is basically the SGFR store, let's be honest. Even though there are many of each product, we can rewrite it as a set by putting these curly braces around it, and each item here is called an element. So using this notation, we can say that Prime is an element of set A. Now imagine we have another Supermarket B that sells Coke, Feastables, and Skittles. We can actually draw the Venn diagram of A and B, and since Feastables is being sold by both supermarkets, it's the intersection of A and B over here. Now, the union of A and B is kind of like combining all the items that both of them sell, which is Feastables, Prime, Doritos, Coke, and Skittles. There's something called a universal set, which is kind of like the boundary of our Venn diagram. So let's say it contains all the food items in the world, so stuff like coffee and McDonald's that are outside of the Venn diagram, but it's still in our universal set. Now imagine a new Supermarket C just dropped, where they just sell Prime. We can say that C is a subset of A because every element of C is inside A. And we can also say that C is a proper subset of A if C is strictly smaller than A. And this time they can't be equal. Now an empty set is when there's no elements inside. So for example, the intersection of P and Q here is an empty set. Okay, sometimes questions will ask you to shade stuff, kind of like the OAS sheet. To understand the idea of the complement of a set, it's kind of like inverting everything in this. So it goes from A being shaded to everything outside of A being shaded instead. So to shade A prime union B, let's first shade A prime, which is everything outside of A, and then we shade B. Now since it's a union, we layer them together and then we shade whatever that's colored in. So it's this whole area over here. Now if we want to do A prime intersect B, again we can layer them on top of one another, but this time we only shade the region where both of the colors are shaded in together, which is over here. For a question like this, the first step is to identify the universal set. So in this case, the universal set is the numbers from 2 to 8. The important thing is that everything in sets A, B, and C has to be from the universal set. So for set A, the factors of 40 are just 2, 4, 5, and 8. Now, for set B, we sort of have to test for each value of x that if it's squared, it's less than 30. So since 2 squared is less than 30, 2 is a part of set B, and so is 3, 4, and 5. But 6 onwards is not anymore because 6 squared is 36. And for set C, we can test if 2x minus 1 is less than 7. So 2 bracket 2 minus 1, which is equals to 3, and it is less than 7. So the element 2 is inside set C. And we just repeat the process and we get the set of 2, 3, and 4. Now to find A prime, we just take a look at the elements that are inside our universal set but not in A. So A prime is the set of 3, 6, and 7. Because set B is 2, 3, 4, and 5, we want to find the intersection between these two. So the elements that appear in both of them is just 3. Now to find the number of elements in B union C, we first find B union C, which is kind of like combining them together, but note that the elements can't be repeated. So it's just 2, 3, 4, and 5, so there's 4 elements inside here, and that's our final answer. Now the next two are probably the most difficult kind, so in order to shade whatever this mess is, the trick is to break it down. So let's try to shade A prime union B prime first. So A prime looks like this, and B prime looks like this, and we just overlap it together. Now A union B is way easier, so it's just like this over here. Now from these two, we can just layer them on top of each other and take the intersection, which is over here, and we just shade it in, and that's our final answer. For this kind of question where they ask you for the set notation for this region, since they are separate, we split them up into region 1 and region 2. Now, using some eye power, we can tell that region 1 looks like the intersection of A and B. Now, for region 2, it's a little bit more difficult, but notice that it's outside of A and B. So A union B, we have to take the complement of this whole thing over here. Now, since we want both regions 1 and 2, we can just join these two together with a union and then we are done. Now imagine there's 10 axolotls that took a test and we arrange their scores in ascending order. We can actually represent this in something we call a cumulative frequency curve, where the x-axis is the score and the y-axis is the cumulative frequency. So here it represents the first axolotl, which has the lowest score, and this here represents the top scorer, and you notice that the cumulative frequency is 10, because all the other people are lower score than him. How this graph is actually really useful is if you want to find the fifth guy's score, and you can draw a line from the y-axis until it touches the curve, and we bring it down to find this person's score. So sometimes the question will ask you to complete the frequency table using the cumulative frequency graph. So for the parcel masses of 0 to 2 kg, we just read off the graph of x is equal to 2, which is 8 minus 0, which gives us 8 parcels. Next, for the masses between 2 to 4 kg, we just read off the 4 kg value, which is 30, and then we minus off the 2 kg value, which is 8. So 30 minus 8 gives us 22 parcels, and we just repeat this for all the masses, and then we are done. To estimate the median, you can think of it as the 50th percentile. So if we just do 50 over 100 times the number of samples, which is 100, it works out nicely to be the 50th position. So on the y-axis, we read off 50, and we can get the median of 5.2 kg. Next, the formula for the interquartile range is the 75th percentile minus the 25th percentile. So in this example, the 25th percentile is position 25. We read it off the graph and we get 3.8 kg. We just do the same for the 75th percentile and we get 6.4 kg. So then the interquartile range is just 6.4 minus 3.8, which gives us 2.6 kg. For the last part, because parcels above 8 kg are rejected, we read off the graph at 8 kg over here and we can get the cumulative frequency of 92. Now what 92 represents is the number of parcels that are below 8 kg. So we just have to do 100 parcels minus 92, which gives us 8 parcels that are overweight. Another way that data can be represented is called a box and whisker plot, and trust me, it is so much easier. The two whiskers at the end represents the minimum and the maximum value, and the range is just the maximum minus the minimum, which is 28 minus 15, which gives us 13. Now the box in the center has 3 lines, where the center line here is the median, and the other 2 lines are the 25th and 75th percentile respectively, which makes calculating the interquartile range super easy. So it's just 25 minus 18, which is just 7. Let's take a look at these two datasets over here, and even though both of them have a mean of 60, their standard deviation, which is how spread apart the data points are, is very different. The whole idea is trying to see the difference between each data point and the mean, and then squaring it and putting it all in this crazy formula over here. So the first step is to create a table with all the x values, and in the next column, so let's say for the value of 42, we just do 42 minus the mean of 60, and then we just square the whole thing to get 324. And we just repeat that for the entire table and sum up all the x minus x bar square values over here, which gives us 638. Because n is the number of samples, which is 5 samples, we just put these two values in the formula, we square root it, and we get our standard deviation of 11.3. So let's say apparently the test was too difficult, so the professor decided to add 10 marks to everyone's score, and we call this dataset 3. You might think that we need to recalculate the mean and the standard deviation, but let me teach you a little trick. The mean value is just the previous mean of 60 plus 10, so it equals to 70 marks, and the standard deviation doesn't change because the difference between each individual value and the mean doesn't change, so it kind of like all moves up together, so the standard deviation is the same. The most difficult kind is when they give you group data like this. First we gotta find the mean, and then we gotta construct the table and then find the midpoint for each category and then find our fx. Then we just sum up the fx values and we divide it by the sum of f, and we get the mean of 53.125 kg. Now notice that the standard deviation formula in the formula sheet is a little bit different, but this part over here is just the mean squared. Next, we gotta create a new column called fx squared, and we just multiply the f with the x squared, and then we sum up the whole of the fx squared column to get 114200. Now we can just use this value divided by 40, which is the sum of f, minus the mean squared, which we calculated just now, and this will give us the standard deviation of 5.72. I also heard there's some calculator method where it sort of calculates it just for you, which is in the description by the way, but I've never used it before, so I don't know, man. If you're a no-life gacha gamer that just pulls for characters, this will be the most useful topic in the whole of eMath. So, for this question about a 6-sided dice, for part A, I'm gonna teach you a pro tip. When you see like you're rolling a 1 or a 6, it probably means that you need to add up the two probabilities together. So since each of them is 1 over 6, we can just do 1 over 6 plus 1 over 6, which is 1/3. Now for the next part, because we're going to throw two dice together, they are independent events because they don't affect one another. Because we want a 6 and then another 6, we need to multiply the probabilities together. So we get 1 over 6 times 1 over 6, which gives us 1 over 36. For the last part, we gotta draw out something called a possibility diagram. So here represents the first row and here represents the second row. So this box here represents throwing a 6 and then throwing a 6 again. Now we can put a tick where the dice are the same number, so we have 6 6, then 5 5, then 4 4, and so on, and we just put a cross on everything else. So there are 6 ticks over 36 different outcomes, so the probability is just 1 over 6. Another kind of really popular question is about drawing two balls consecutively from a bag. And because it's without replacement, once one ball is taken out, the probability actually changes for the next draw. So let's draw our probability tree diagram, and because there are 18 balls in total, the probability of getting a red is 10 out of 18 and the probability of getting a blue is 8 out of 18. A quick note is that all the branching possibilities for one branch here must add up to 1. If not, you just probably messed up somewhere. Now imagine if we drew a red ball at a first draw, so now there's 10 minus 1, which is 9 red and 8 blue left. So the probability actually changed for drawing a red, which is 9 over 17 and the blue is 8 over 17. If we drew a blue on the first draw, there is still 10 red and 8 minus 1, which is 7 blue left. So to draw a red, the probability is 10 over 17 and 7 over 17 for a blue. You notice that the probability actually changes depending on if we drew a red or a blue first, which is why we call this a dependent event. For part B, we want to find the probability of drawing both blue balls, so we have to traverse down the tree diagram. So blue is this path over here. And traversing down a path, we multiply the probabilities together, so we can just do 8 over 18 times 7 over 17, which gives us a probability of 28 over 153. For the last part, the question says it wants one red and one blue. It's very important. We always need to consider multiple ways of getting it. So we have to consider both drawing red first, then blue, or drawing blue first, then red, and then add those probabilities up together. So for red then blue, it's this pathway over here. So it's 10 over 18 times 8 over 17, plus the pathway for blue then red, which is 8 over 18 times 10 over 17, and that gives us the final answer of 80 over 153. I think they added in this topic because it kind of teaches you how Excel works. So just like Excel, a matrix is kind of like a table. So for example, this matrix here has a dimension of 2 times 3 because it's 2 rows by 3 columns, and it's always rows times columns. If you forget, there's a pro tip I like to remember that columns has an L inside it, so it's kind of like vertical, you know? Matrices can only be added or subtracted from each other if they have the same dimensions. So the first step is that we can kind of expand this 2 out into each element of matrix B like this. And then to add these two matrices together, we just have to add the individual elements together. Now, multiplying matrices is a little bit more tricky because this time the dimension and the ordering of the matrix actually matters. So let's write out the dimensions of A and B, and the first thing you gotta check is these two numbers next to each other. If they are the same, only then the matrix multiplication is valid. And then the dimensions of the output matrix is just these two numbers over here, so in this case it's 2 times 2. To get this top left element over here, we kinda know that we need to multiply this row by this column. So you know one of those sliders? So yeah, imagine the slider starts at the 2 on this row and the 1 on this column, so we just multiply these two together. Then we shift the slider for both of them, and then we multiply these two elements together as well, and then we add it to the previous one, until the slider reaches the end, and we get the top left element of 11. And then we just repeat the same steps for the elements in the new matrix, and ta-da! We are done. A really popular question in the O-levels is what I like to call the long matrices story time question. So for part A, we gotta find the dimensions of the matrix S and the matrix C. Okay, pro tip, we take a look at the next part and we can kinda see that it's multiplied to P, so it must be 3 times something because of our matrix multiplication rules. So we know that it's a 3 times 1 matrix, so matrix S is the sell price like this, and matrix C is the cost price like this. Okay, let's multiply matrix PS together, and you can see that for this element over here, the row is shop A. The number of square steel sold is multiplied by the sell price of the square steel, plus the number of wood veneers sold is multiplied by the sell price of the wood veneers. You can kinda start to see the pattern. So after doing the matrix multiplication, this 16x plus 594 is the total selling price of all the items in shop A, and this one here is for shop B. When we multiply PC together, it's kinda like basically the same thing, but this time it's the cost price for shops A and B respectively. Now if we sort of expand this matrix, we get PS minus PC, which both of them we already found. So working out this matrix over here, it just represents the profit, which is kind of like the sell price minus the cost price for both shops. Okay, now for the last part, it asks you to solve for x and y, and since there's two unknowns, there's probably a good chance that you need to solve for simultaneous equations. So adding all of this up over here represents a number of tools in shop B, which is 10 more than A, so we can construct an equation and simplify it like this. Now since they also said that the profit for shop B is $109 more, we can construct another equation using this matrix over here, and we can get our second equation. Now we can just solve for these two equations simultaneously to get the value of x is equals to 22 and y is equals to 20. Imagine we have a simplified version of the MRT map with only 4 stations, and the train is going from Tanah Merah to Paya Lebar, so we call this vector TP because it's in this direction. Now if we want to find the vector from Tanah Merah to Serangoon TS, since there's no direct MRT, we have to go from T to P, then P to S. So the vector TS is actually equal to TP plus PS. Now imagine if we want to go from Serangoon to Bugis over here, it's equal to negative PS because you're going the opposite direction, plus PB. A vector can also come in the form of a graph. So to find this column vector AB here, to get from A to B, the x value increases by 5 units, and the y value increases by 6 units, so vector AB is 5, 6. To find the magnitude, it's basically Pythagoras theorem, since we want to find the length of this vector. So it's square root of 5 square plus 6 square and we are done. If we have this other vector CD which is equals to 10, 12 here, let's try to factorize a 2 out and we notice what's left is the vector AB. So we can say that CD is equals to 2 times AB. This 2 over here is called a scalar quantity, and if two vectors are kind of equal to each other with some scalar quantity, they are actually parallel to each other. So CD is parallel to AB and is 2 times longer, so it may look something like this on the graph over here. It is now time to put it all together to face the long vectors question, and it's kinda like the MRT map example. The first part asks us to represent AB, so we can go this way, which is negative A plus B over here. Now for vector BD, we can go this way, and again since it's the opposite direction, it's negative BM, and we plus MD over here, and we do some algebra and we can get 2B. Now to find vector CD, the strategy is to do CM plus MD, And we know that vector CM is equals to MA because it's the same direction and it's given in the question over here. To find MA, we can do MA minus AB because we can just use the AB value from earlier, and doing some calculation, we can get vector MA equals to negative A. Now, vector CD is just CM, which is negative A, plus MD, which is 3B minus 2A, and we managed to prove this part over here. For part C, we want to prove that these two triangles here are similar. So if we factorize out a 3 from vector CD, it actually gives us the vector AB. So we know that CD is actually parallel to AB. Now we can start by saying that this angle here is a common angle between them, and then these two angles here are corresponding angles since AB is parallel to CD, and we managed to prove it using the AA similarity test. Whenever the question asks you to find area ratios like this, it's usually either two methods. The first being the half times base times height method, and the second being the similar triangles area method. Since they literally told us to prove that this triangle is similar to this, and CD is 3 times the length of AB, the area ratio of the small to the big triangle is 1:9. Now since they want the quadrilateral ABDC, it's 9 minus 1, which is 8 units squared. So, the final ratio of triangle OAB to ABDC is 1:8. At the last question of every math paper too, it's basically a long question where they give you a chunk of text that you have to read through and solve some real world scenario. Like, bro, I signed up to do math, not to read an essay. It's quite tough to prepare for because they can literally be from any topic, but usually it's something to do with money or rates. Usually they don't require any super fancy math, but my pro tip is to number 1, to use some common sense, and number 2 is to try to justify why you chose a certain value. Okay, so let me walk you through an example from the O-Levels 2020. And the story talks about this broke college student wanting to study overseas and her parents need to send her money. And after some simple calculation, we can find out that she needs about £20,000 per year to survive. Now, the question is, which value do we take when we want to convert it to the SGD by reading this graph over here? A general principle for these kind of budgeting problems is that we want to use the worst case scenario, because we don't want her to end up running out of money and being homeless and dropping out of college, you know? So let's take a look at both the maximum exchange rate of 0.58 and the minimum exchange rate of 0.5, and we do some conversion like this, and we can see that the exchange rate here gives us a more conservative estimate, whereas for this one, she'll probably end up broke if the exchange rates ain't looking so good in that month, you know? This is another question from 2022, and this time the story talks about two sweatshop workers, Chen and Zhu, making necklaces. And we gotta calculate whether they can make necklaces fast enough to earn minimum wage. Chen and Zhu, are you okay financially? Blink twice if you need help. I know you have bigger dreams in life than making necklaces all day. It's time to achieve what you always wanted was to become.
Can you just go back to the math question?
Okay, chill. For this question, we need to let t be the time taken for Zhu, and then t plus 80 is the time taken for Chen. Now we gotta try to form an equation. So since both of them work 8 hours a day, we need to convert 8 hours into seconds, because they are in seconds here. So 8 times 60 times 60 divided by t is the amount of necklaces Zhu makes, and 8 times 60 times 60 divided by t plus 80 is the amount of necklaces Zhu make, and both of that adds up to 132. Now we can just combine the two fractions together like this, and then we cross multiply. And then we can simplify everything to get a quadratic equation in terms of t like this. And yes, I totally understand everyone will be super confused by the big numbers, but it's all good. Then we have to use the quadratic formula to solve for t, and we can get 400. So Zhu takes 400 seconds to make each necklace, and then the rest is pretty simple from here. You know, something mysterious actually happened to Chen and Zhu, so I hope you're ready for some lore! Chen actually made a reappearance in the 2023 O-Levels, but Zhu was nowhere to be found. Okay, if you look at the solutions for the 2022 paper, it says that Chen didn't make the minimum wage, but Zhu did. Maybe that's what pushed him to ditch Zhu and quit his necklace making job. and apparently start his solar power panel home refurbishing business. Wait, is Chen secretly the galvanized square steel guy? But hey, that's just a theory, an O-levels theory. Thanks for watching. Wait, before we end off this series, I just want to throw in a bonus question because I think this one is actually pretty useful in life. When you, dear viewer, become super rich and you're looking to buy a car in Singapore, you will remember back to the time when Axie the Axolotl taught you how to read this registration fee table to calculate that amount that you have to pay. So imagine if you want to buy a Tesla that costs $69,000. So based on our table, since it's not above $80,000, let's split the $69,000 up into the first $20,000, then $30,000, and then the remainder, which is just $19,000, and all of these is basically $69,000. Since each one is taxed differently, we can just do $20,000 times 100% plus $30,000 times 140% plus $19,000 times 180% to give us our total ARF fee of $96,200. Okay, one last thing. I just want to thank Paradigm Math for uploading this eMath cheat sheet because it's an absolute lifesaver and I highly recommend all of you guys to go and download it and print it out. And thank you for making it free because your favorite axolotl is way too lazy playing Valorant.
As your favorite Axolotl production manager, what a journey has been from the first video until now. If you've watched the entire series, I just want to say a big thank you, because you must have been really desperate to pass O-level math IC.
And that is it, the end of a series. I hope these videos managed to help you pass with flying colors for O-levels. Thank you so much for watching my math videos and showing me so much support. And I also like to thank my production manager for constantly feeding me with a lifetime supply of instant ramen and coffee. Cheers to the end of a series.
Unless, I think I have an idea for one last math video.